we're the laser sharks, and our project is called Rinsing BOD and Water Volume. A little overview of our presentation. It is divided in three main parts: the define phase, where we're going to present our problem; the measure phase, where we're going to present our methodology to collect data and the data we collected; and the third part is the analyze and improve phase, where we're going to present the analysis we did on the data we collected on the measure phase and suggest some improvements. The define phase. First, a little background information so you all can know where our problem is. The cheese process is basically that the raw milk is pasteurized and it goes to the cheese vats where the enzymes are added, and the whey is drained, and then the cheese go to the hoops to be pressed. And when they're ready, they're removed and packaged. But when they are still in the hoops, whey keeps being expelled, and this whey has high BOD. So one of our problems is that this whey is going down the drain, so there is a high amount of BOD going down the drain, and it's too high. And it's caused environmental concerns because environmental agencies can shut down if the BOD continues high. Another of our problems is that the water volume used to rinse the floors is too high. The creamery floors are rinsed throughout the cheese making process, and the biggest rinse is at the end of the production. All the employees rinse the floors, and there is no recovery of this water used. And there's also no measurement of the water they use to rinse, and they also clean all the equipment with this water. And there's no measurement, so there's only an estimate of the total water used.
So a briefly definition of biochemical oxygen demand, or BOD, is that the BOD is the amount of dissolved oxygen needed by an aerobic microorganism to break down the organic material in a sample of water in a specific time during a certain temperature. So usually the time used to do this test is 5 days, and the temperature is about 20 degrees Celsius. During the cheese making process, the whey is collected into a bucket, and it is allowed to overflow and run in the drain. And at the end of each day, the whey is the bucket is emptied in the drain. Sorry. So this whey, which has a high BOD, can cause environment issues. So unfortunately, we had some problems to do this part of the project because the creamery does not have the equipment that we needed to measure and to analyze the data. And also, as I said before, the test takes around 5 days to be done, and it could be difficult for us because we could not have enough time to do an efficient result. So because of these limitations, our main focus was on the reduced water used to rinse the floors on the creamery, at the creamery. So in this slide and the next one, we have our project charter. That is a document which contains some information about the project. So we have as title rinse BOD and the water volume. Our problem statement, as Gabriel said, it was to reduce the water used to rinse the floors and rinse BOD. Our goal statement was to reduce the amount of water for rinsing the floors, and our scope includes employees, water volume used for rinse of creamery floor. And in this part of the charter, we have some stakeholders for the project, and the estimated cost is not available because we didn't have costs with this project. And here we have our deadline to do this project, and this part presents some notes that we learned during this project.
So next is our measure phase. So during our measure phase, our goal of this phase was to calculate the amount of water volume that is being used to rinse the floors, in order for us to be able to see what aspects of what problems are causing the water usage to be higher or low in the creamery. So our variables that we've encountered during this project were the employees, the time of the day, the area of processing, and the day of the week. So due to the lack of equipment, like Gustavo said, and also the time for us to be at the creamery recording or calculating the water volume that is being used, so we implemented a plan to measure the amount of water usage. So we created a log sheet, which is not there. We had a log sheet that we had the day, isn't it here? No, it's not there. So I'm sorry, but we had a picture where it shows the log sheet that we did, and it had the day, the name of the employee, the time of the day, and the time that that person has spent using the water while rinsing the floors. Because we were not able to be at the creamery, so we talked to the employees and asked them. We explained the project goal and why we're doing this and the importance of measuring the water volume, and asked them to record every time they use the water to rinse the floors. This was for a week that we implemented this project, and we only focus on the vital few of the most used hoses in the creamery to kind of estimate the water volume. So, and also we had a special place or a special box and log sheet where employees could write if there were some kind of complications during the cleaning the floors, like the water pressure was different, or it was maybe dirty than usual, like different color or anything like that, that it could like put on a note on the timesheet, on the log sheet, sorry. So once we collected the data for after a week, so we wanted to measure the total water volume used during that week. So we measure the time that it took to fill up a 5-gallon bucket, and then we'll multiply that by every single time that the employee was using the water. So it was 5 gallons, and well, first of all, it was 45 seconds to fill up a 5-gallon bucket, but because we want to use minutes, so that equals to 0.75 minutes. So it was 5 gallons per 0.75 minutes. So then we wanted to graph all these data to be able to see the variables or the impact of the employees using the water. And on here we can see that on October 16, there was a really high volume of water being used, and it was around 1,400, almost 1,400 gallons of water. That was really high compared to the other days here. It's a huge jump, and you know there might be reasons why that we're gonna talk forward. We use a bar chart so you guys can see better that on October 16, the water volume usage was really high compared to the rest of the days. The average was 636 gallons. And we also wanted to use a control chart to see the variability and also the moving range of our data. These are the upper control limits. If there's any point outside of those limits, that means the control of the process is out of control, or if it's lower than that. So it shows that it's in control, but there's like some changes here on the same days. This is the moving range, and also you can see that the process is in control, but there's some variation on here. So problems that it could affect this data during this project was the employee cooperation. Sometimes we noticed that employees were not recording the times, and that could be because they were busy or they couldn't record the times. Maybe there was like a different pressure in the hose. So this was like an estimation for all the water usage during this project.
Okay, so then I'm going to talk a little bit about the analyze phase. So for our data analysis, we performed a one-way ANOVA. We chose a one-way ANOVA because there were more than 2 treatments. Since the data was collected over 9 separate days, and since we are only looking at the day factor, but since there was more than 2, we had to use ANOVA to see if there was a significant difference. And so our factor was the day, and we wanted to know, is there a significant difference of the water being used between the days? So we needed some assistance while we were calculating our ANOVA because each one of the days had were varying in their subgroup sizes. So we actually talked with Dr. Joyner, and we used SAS software, which is known as, it's a statistical analysis software, which is able to perform the ANOVA with the varying subgroup sample sizes. So it was over 150 observations, 9 different sample days. Our null hypothesis was that there is no significant differences between the amount of water used to rinse the creamy floors on different days. And so our alternative hypothesis was that there was a significant difference between the amount of water used to rinse the creamy floors on different days. So this is our ANOVA table that was given to us from the SAS program. So our treatment was the day. We had 8 degrees of freedom because we had 9 days, so since it is 1 less than the total. The sum of squares was 8,589 and 82 hundredths. Our mean squares was 1073.73. Our F value was 0.89, and our P value is 0.5296. The SAS program also did not give us a complete ANOVA table that includes the errors and the total. It just gave us the treatment, so that made it difficult to get an F critical value, which Colby will talk about in 2 seconds.
So from the table from before, this is our distribution of observations, and I will go into detail with the next slide. So here's the ANOVA results. As you could tell from before, the p-value is large and the f value is close to 1. So this means that it is indicating that there is little or no difference between the days. And since SAS, as Annie talked about before, doesn't complete a full ANOVA table, leaving the F critical value not to be found. So technically, since there wasn't the F value to be found, we couldn't compare that to the F value that was calculated. So we inferred that since the p-value or the F ratio was close to 1, that we can infer that there was no significant difference, so we fail to reject the null hypothesis. Also, you can tell from before that there's a high amount of standard deviation, which is indicated by these little whiskers. This could be due to the fact that, as talked about before, not all employees recorded the exact amount of time and the exact, and yeah. So we failed to reject the null hypothesis. The null hypothesis was looked at in days, not in time of day, employee, or area being rinsed. We couldn't do those three factors because, as talked about before, there wasn't a consistent recording of times being used for using the rinsing hoses. So issues, the data is based on estimations and assumptions. The assumption is that the pressure and the flow was the exact same every single day. This isn't necessarily the best assumption, but it's an assumption that we had to make because we're not there every single day to test the amount of flow, to test the amount of pressure, etc. And also, there's estimations made that the amount of time was being, the same amount of time was being used to rinse. If an individual was using the hose and they recorded, 50 seconds, well, they may be using the hose for 5 seconds, turn it off for a couple seconds, use it a couple seconds again, and so on and so forth. So the estimation was made that the entire time they were using the hose. And this was a little difficult to implement in any situation. So some improvement suggestions. One suggestion is to train the personnel and so they can efficiently use the water or use it as most efficiently as possible. We could implement low flow nozzles. However, there's some issues with this that it could take them longer to rinse the floors, which isn't always the best thing because they have other stuff to do. And it could also, since it's low flow, the amount of water coming out might not be enough to actually clean the floors and do the task at hand. So this could create an issue. And the last one is to implement high pressure nozzles, which could be a little better of a suggestion because since it'll increase the pressure, there will be less water needed to be used, and they could also possibly rinse the floors faster. So, any questions?
Yes.
This was a hard one. So since we don't have any meters on the water, that makes it pretty tough. And since you guys weren't able to be there 24 hours a day to watch this, we were relying on students or employees to try to gather data. And, in my former life, when we had consultants come in to help us with problems and stuff, this was always a big issue, is trying to get the accurate data. So if you were to be in this class again next semester and were assigned the same project, what would you do differently?
I would try to spend more time personally recording how much time employees were taking to rinse the floors, because a lot of times they would forget to time it and record it, so that was based off of an estimation. We could implement the flow meters onto the actual hose itself to see how much was passing through to try to measure it that way, but we just didn't have any of that equipment available to us when we needed it for this project. We could, if we wanted to try to keep using the employees for the help, try to simplify the log sheet, just so it, instead of asking for name, initials, all these different things, just ask for the simple amount of time. There were a few things I think could have gone differently.
Well, what I noticed when I was working at the creamery was that the fact that employees were not recording the times, it was the lack of supervision or motivation to enforce that. So if I will have to do the project again, I will probably ask one of the managers to assign one person one of the employees, if us cannot be there, like it happened this semester, to actually record how much water is being used, or like watch the employees who are cleaning the floors and record every single employee every single time they use the water. Maybe that could be more accurate too.
Or even offer maybe an incentive, maybe a candy bar or something.
But I mean, with that, we also realize that the employees at the creamery are busy, and so they might, and that they're trying to, produce a product, so they may not have an extra person to do that, but we could try to do something to get someone there full-time to manage it, whether it's one of us just on a rotation or try to work something out.
Yeah, I think, what motivates employees, they've got a task to do, and they get paid for doing that task, and then when we ask them to do something out of the ordinary, it's difficult, and so, it's no matter which facility we go into to try to gather this information or have the folks in the plant gather information, it's going to be difficult, so we need to look for methods and ways to either motivate them or alternate ways of gathering information so that we know or have a better idea about consistency or accuracy.
What happened that particular day where you had that 1,400? Was that like a double cheese batch day or something?
Well, double cheese is usually ran on Mondays, not on Fridays, and that was actually a Friday. We are not sure. It could have just been on this day, a lot of employees just decided to record, and on other days they might not have. It could have been, maybe it was the next day and people because I know I get messed up on dates pretty easily, and I just look at the one above me, and if someone before wrote it was the wrong day, so it could have been something like that. There's a variety of things that could have caused that, or it could have just been, it was a messy day that required a lot
Yeah,
more.
I was gonna say that it was at the end of the week. I think it was Thursday. So maybe because it's the end of the week, they're trying to leave everything clean for the next week, maybe.
If it was a Thursday, it's a possibility that we ran ice cream that day, and there would have been additional cleanup for ice cream.
Okay, so it was a Thursday, yeah, so that's what I thought, maybe the type of processing that was going on that day.
It would have been, one area, the ice cream area would have been additional to what happened on the rest of the days.
And in theory, we wanted to try to limit it to not include the ice cream area, but I mean, it's kind of difficult.
Yeah, one of those is right next to the ice cream area.
Mhm.
Questions from the class?
I guess another question about the DOD. That it is important for us to know about that, and I know that how difficult it is to get those figures, because the only way we can get them is to pay somebody to run the test, or somehow convince the city of Pullman to run the test. But that is pretty important to us, so I don't know if there's alternative ways of getting samples and getting them tested, if there's any testing that our food science department can do.
I mean, like, I talked to a couple people in the cheese making industry, and the chemicals that are required for the testing, I'm pretty sure they said are not available to students. They have to actually be sold to an industry because they're extremely, carcinogenic, but they're also extremely expensive. And that really, I mean, besides the fact that we can't get them, even if they were available, it wasn't in our budget.
There's also a significant amount of training that you need to do to be able to do the VOD test repeatably and reliably.
And each test takes about 5, and we just didn't have the amount of time to be able to get enough samples and run all the data.
One more comment. One of your solutions was to add a high pressure. We probably would not do that because when you're hitting the floor with a high pressure nozzle, you tend to make aerosols. And we have enough stuff floating around in the air with our cheese exposed that we try to stay away from the high pressure nozzles. So
Yep.
probably, more squeegee use, less hose use to get move stuff across the floor. It takes a lot of water to move one piece of cheese across the floor. And you can just either pick it up or squeegee it to the trash can.
Other questions?
Frank?
Frank? Oh, I was like.
All right, if nobody else has any other questions, I have 2 questions for you guys. Going back to your ANOVA table.
Okay.
You actually don't need additional information to be able to say whether or not you can reject the null hypothesis from that table, and it has to do with your p-value.
Okay.
Do you guys remember how to make a rejection based on p-values?
From what I went and I looked at it, and I also talked with Dr. Ross because I was over at WSU when I was working on it. She said that the p-value should be around 0.05.
Correct.
And so if it's significantly higher than that, then you can base that off of to reject the null, or fail to reject the null hypothesis.
Yes. Yes. So you do actually have enough information in that table to make your decision on that. Just know that SAS defaults to 0.05 for alpha.
Well, and the reason we commented on that, that was one of the notes, and we might have just phrased it wrong in the report, but saying something about we needed an F critical value.
Okay. You do need an F critical value if you're comparing your F value, but if you're using your P value to make the decision,
Then
then you
that's
don't
okay.
need that
Okay.
critical value. Yeah. Okay. So that's good. And then my last question for you guys is, you had several recommendations. Which is your top recommendation for the creamery?
Personally, I would go to training personnel, like what was suggested, using a squeegee. Like you can try to remove as much debris before training them to remove as much debris instead of trying to spray one piece of cheese down the thing. That would significantly reduce it, and then you can just do a quick rinse after to get anything less, and I think that could significantly reduce it.
Okay. Other questions?
I got one other question. Sorry. Near the beginning of the presentation, you were explaining what BOD was, and you said it was biochemical oxygen demand.
Yes.
I guess I thought there was biological oxygen demand.
It's known by both.
Okay.
Yeah. When we looked it up on the internet, we were able to find it both, but they both have the same definition. It was just biochemical versus biological.
And the test for it is the same.
Mhm.
Okay, great.